Good morning. In the last class we had seen the latitude effect of cosmic rays. Today we are going to discuss about longitude effect as well as altitude effect of cosmic rays. So what are longitudes? They are also known as meridians, which starts from north poles and ends in south, and they are equal in length. So these are the lines of longitude. Now what is meant by longitude effect? The intensity of cosmic ray at a given latitude and altitude varies. This phenomenon is known as longitude effect. What is the cause of longitude effect? Longitude effect is due to the eccentricity of the Earth's magnetic field caused by the displacement of Earth's geomagnetic field center. Here we have the Earth's magnetic field. You can see in red lines the North Pole and South Pole. But the geographical North Pole as well as the geographic South Pole has got deviated from the actual North and South Pole with an angle 11.5 degree. So the Earth's geomagnetic field center had a displacement, and due to this displacement there is a deviation of the Earth's magnetic field, which is the cause for longitude effect. So longitude effect is due to the deviation of Earth's magnetic field caused by the displacement of the Earth's geographic North Pole or geographic geomagnetic field center. So we can consider Imax and Iminimum as the maximum and minimum intensity of cosmic ray at two longitudes with same latitude and altitude. So the ratio Imax minus Iminimum divided by Imax gives the measure of the longitude effect. We had taken Imax as the maximum intensity and Imin as the minimum intensity at a particular latitude and altitude. And we can calculate this value, and it was found that it amounts to 5% at the geomagnetic equator and decreases to 0 at higher altitudes. We don't have a graph to see this variation. So you have to know how we can measure the longitude effect and how the value varies at equator and higher altitudes. So that's about the longitude effect. Next is altitude effect, in which the intensity of cosmic radiation varies with altitude. So the intensity of cosmic radiation increases with altitude, indicating that it comes from outer space. We know that cosmic radiations are the radiations coming out from the extraterrestrial sources like sun, stars, etc. So as we move above from the earth, as the altitude increases, we can see that the intensity of cosmic rays also increases. So let's have a look on the altitude effect, where we study the variation of cosmic ray intensity with altitude. So in the graph, altitude is taken along x-axis and the intensity of cosmic ray I is taken along y-axis. So as the altitude starts increasing, the intensity also starts increasing. And at a particular point, you can see that the intensity after reaching a peak value goes on decreasing. So what is the reason for that? And the graph is shown for 3 different longitudes, that is 3 degree north, 38 degree north and 51 degree north. So here you can see that the intensity of cosmic ray increases with altitude and it attains a peak value and then it starts decreasing. Why? And the answer to that question is shown in the second picture, where you can see that to a certain altitude we can see the cosmic ray showers. Cosmic ray shower is the production of secondary particles, secondary cosmic rays, when the primary cosmic rays interacts with the nuclei in the atmosphere. So more and more cosmic ray particles can be seen in the shower. So the intensity will be maximum. And going upward, you can see that before the secondary particle production, there is only primary cosmic rays which are less in number. So that what happens, the intensity will, as we start from moving from downwards to upwards, we can see the secondary cosmic rays which is more in number than the primary cosmic rays. Then as we go up, there will be primary cosmic rays which will be lesser in number. So that intensity starts decreasing. So that's why we have got a decreasing graph for the intensity of cosmic ray after the peak value. So the intensity increases with altitude and reaches a maximum at a height of about 20 km. And at heights above 24 km, the intensity gradually decreases. The position of maximum intensity indicates that the energetic primary cosmic rays on entering the atmosphere interact with the nuclei of the atmosphere and produce secondary particles whose ionizing power is greater than those of the primary particles. Above the maximum intensity, the interaction is less, and so that the intensity of cosmic rays decreases. This is the graph showing how we measure the cosmic ray intensity at different altitudes. So up to 5 km altitude, they studied using mountain stations, and aeroplanes is used for the heights up to 12 km. And then they used balloons to attain a height of 18 km, unmanned balloons. All these will have self-recording instruments in order to record the intensity of cosmic rays. And above this height, rockets and of course satellites were used to measure the intensity of cosmic rays. So here you can see the cosmic ray showers. So from the up, they are primary cosmic rays which are less in number, and on entering the atmosphere, they interact with the nuclei in the atmosphere and produce a secondary particles. So as we go from the Earth's surface, the intensity got increased, then attains a peak value, then got decreased. So that's about the altitude effect. Thank you.